Hello learners, welcome to Math. So learners, in this video we'll see some concept about sliding window protocol and coding problem based on that. Okay. So what is a sliding window protocol? So sliding window protocol is a technique which is an efficient way to solve problems which involves subarrays or substrings by reducing unnecessary recalculations. So it is basically used in problems where we need to find one a solution for every possible subarrays or substring or fixed or variable length, such as finding the maximum sum of subarrays of a fixed length or finding the longest substring that meets a certain condition. So now just see an example of it with which you will understand it in a better way. Okay, now so see over here. So here's a coding problem. So here we have given an array of n elements. Okay, so we have to return maximum subarray sum of length k. So here k is what? K should be greater than 1 and it should be less than equals to n, and which is what? The number of elements in the array. So you can see here is a given array. There are some elements in it, and here k is given as 5. So all subarrays with length equals to 5 is given over here. We can see that. So starting from index x to index e, and here's the sum. So if we have to get a subarray of length 5, so which we are starting from index 0 to index 4. This is this contains 5 elements, you can see. Okay, and the sum of here it is 7, like that from starting 1 index 1 to index 5. This is a subarray of 5 elements. So here the sum is 8, like that from 2 to 6. The sum is 12 from 3 to 7. From the sum is 16. You can see from 3 to 7. The sum is 16. From index 4 to 8, the sum is 10, and from index 5 to 9, the sum is 11. So among all these sums, you can see this is the maximum. So this is our answer. Okay, so now just see what can be the solution, how we can achieve it, how we can do that. So just look over here, that here is the array with k is equals to 5, and here's the brute force approach. So here is the pseudocode for the solution one. So over here this is a method which max sum array 1, which are taking two inputs, which is an integer array and integer of k. Okay, k which is this only, this. Okay, now you can see over here that first we will just take an n, which is the length of the array. We are taking the source index, starting index, which is equals to 0. E is the ending index for the subarray, which is k minus 1. Okay, now for the answer, we are initiating an answer with the minimum value of the integer. Okay, now just see over here, we are taking a while loop. Okay, where there is a condition e should be less than n. Okay, now we are initiating a sum which is equals to 0. So now there is an inner loop inside this while loop. Okay, so here we can see that for I is equals to s, I should be less than equals to e and I plus plus. Okay, and here we are just increasing the value of the sum by with all elements in the subarray, which is such as ai. You can see this ai is a each element for the subarray from s to e, and we will add all these elements, so the sum variable. Okay, now after this end of this inner loop, we are just taking the max of the answer and the sum, and we will put the maximum value in the answer variable. So now we are incrementing this s, and also we are incrementing e. So now again this loop runs. The sum variable is initiated with 0. The inner loop will again run from I is equals to s to I is equals less than equals to e and I plus plus. Again we will do the sum of all elements in this particular subarray, and we will check for the maximum between the sum and the answer, and we will put the value in this answer variable. We will do it till e reaches the last element. Okay, so now you can see, and at the last, when all these operations are done, we will return the answer. So you can see that over here with an array such as, you can see first of all we start from 0. Okay, and we use what, k minus 1, so k is what, 5, and k minus 1 value is 4. So we will just add all these elements over here. You can see, first of all this while loop starts, and in the while loop some variable is initiated, and in the inner loop we are adding all the elements of the subarray, such as this set of elements. Okay, and again then what we are doing, we are taking the max between the answer and the sum and putting that and the value in the answer. So you can see whatever is the answer we get from here, the maximum value between the answer and the sum we will put in the answer. Again now what we are doing, then we are incrementing s and the e. So you can see over here s is incremented from 0 to I 1, and e is incremented from 4 to 5. So we will find the sum of all these elements, and we will put the maximum in the answer. Like this we will reach till the last of the element from till here, and we will do this all this operation till there. So in this operation we will get the maximum subarray of length k. Okay, so in this operation you can see that here is a while loop which will run for how many times, which will run from n minus e, and e is what, e is just k minus 1. So we will get it will run from n minus k plus 1. It is running from n minus k plus 1, and the inner loop is running from for what, k times. So this the time complexity for this loop is n minus k plus 1, and for the inner loop is k. So n minus k plus 1 will be multiplied with k. So what will happen if k is equals to n? So you can see over here that the time complexity will be order of n. If k is equals to 1, so the time complexity in this case will be also order of n. If k is equals to n by 2, in between any value of between 0 and n, such as n by 2 over here, so what will get, that the order of time complexity will be what, order of n square. So it is so generally the value will be in somewhere between 0 and n only. So we are getting the order of n square in worst time complexity. So can we optimize it? Yeah, we can. Okay, just see another solution. So now in this solution we will use a concept of prefix sum. So if you don't know the concept of prefix sum, just I will add a video in the I button of my video. I have taught it in my previous video, so you can go and learn over what is a prefix sum. So now let's see over here. There is a method which is accepting integer and array and integer k. So n is what, k, the length of a array a. We are adding a prefix sum. You can see we are doing a prefix sum calculation, and now with the prefix sum we have an advantage that we can just get the prefix sum. If you want to get the prefix sum from here to here, then we can just use the formula of the prefix sum for getting the sum of the subarrays, such as you can see over here. S is starting from 0, E is k minus 1, and we are initiating answer is equals to integer dot mean value. So while E is less than n, we are initiating sum is equals to 0. If S is equals to 0, we will get the sum of the subarray just by putting the prefix sum E of the index E. Okay, prefix sum array of index E. So with this we will get the sum of the subarrays from here to here. Okay, since the S is the starting index is 0. Okay, now just see if the starting is if S is not equals to 0, then we will use the formula of prefix sum of index E minus prefix sum element of index S minus 1. Okay, with this we can get the sum, and after that we will just calculate the max dot max of answer and sum. Okay, and after that we will increment S and E, and rest is the same as the previous operation. What we are doing, that we are using the concept of prefix sum. Okay, and last we will just return the answer. So here you can see that the time complexity of calculating prefix sum is order of n, and in the time complexity of for this operation is n minus k plus 1, since this loop runs for n minus e, which will result in n minus k plus 1 only, since e is equals to k minus 1. Okay, so you can see the time complexity of here, that n of the time complexity of n here over here, plus here n minus k plus 1. So it will result in order of n. Okay, now just see that we have optimized the time complexity. Yeah, we have done that, but we are increasing the space complexity of the problem. In the last operation, you can see the space complexity was order of 1 only, because we were not adding any array, and but the time complexity was huge, order of n square. Here we are optimizing the time complexity, but we are also increasing the space complexity. So now, is there any way in which we can also optimize the space complexity? So yeah, there is a way for that. Okay, just see the solution 3 for it. Now what we will do over here, in the same array for k is equals to 5, we will just use the concept of sliding window protocol. Okay, you can see that we are making a window. You can see over here like this. I've just created an icon of this window. So you can see we will just make a window of length is equals to k, which is 5. So here is a window of 5. First of all, we will add all these elements. So the sum of all these elements is what? 7. Okay, now what we have to do, that we will just shift this window towards the right side. Okay, right side. So we have shifted the window towards the right side. Now what you can see that this is a new window. So in this window, this element is taken out from this window, and this element is added in this window. You can see this element is out and this element is in. Okay, so if this element is out, we have to remove, we have to subtract from our sum. So we are subtracting with the sum 7 minus 3, and we are adding a new element. So we will just add minus 2 in this sum. and what we'll get, we'll get the sum as 8. Okay, then again in the next iteration we will just shift this window towards the right side. So in this, now in this window you can see this element is out and this new elements is in, and we will decrease this value from the sum, and we will increase the sum by this value. Okay, now the sum is what, 12. Again we will just shift it towards the right side. We will just towards the right side, and we will out this element, we will in this element. So we are doing the same operation over here. Like this we will shift towards the right side till we get towards the last element. Okay, like this we will just do the operation. With each operation we will check the sum, compare the sum with the answer, and whatever will be the maximum we will put that in the answer, and at last we will get the final result. Okay, see. Okay, just see over here, this is the element. Okay, first of all just we have to sum all this set of elements, and you can see S and E starting index and index and the sum. So from 0 to 4 we will just add and put the sum as 7, and this, for this only we will take the time complexity as of order of k, since the size of window is the size of k. So, and after that we will just use this formula, sum is equals to sum minus array or element of index s minus 1 plus array element of index e. Okay, in the next subarray what we can do, we can just take the sum, previous sum, and we'll decrease the value of a0 and we'll add the value of a5, and we'll get the answer. Similarly we will do for all the subarrays till the last, and for all this set you can see what there is the time complexity for all this calculation, it is order of 1 only. Okay, so here you can see by taking the concept of carry forward plus all subarray of same size, we get the concept of sliding window protocol. Okay, now just see the implementation using a pseudocode. Here is a pseudocode for it. Here we are taking again the integer array and integer k, and is the length of the array a. Sum we have initiated with 0. For first of all we will just add the first set of k elements. Okay, and this will take order of k time complexity. We will get the sum. Now we will take s equals to 1, e equals to k, and we are initiating answer equals to sum. Now here is the loop, e is less than n. Now sum is equals to sum minus array a of index s minus 1 plus array a of index e. We will take the answer by taking the max of answer and the sum, and we will increment s and e, and at last we will return the answer. Okay, now you can see in this operation, first of all here is the order of k time complexity, order of k time complexity, plus here we are getting order of n minus k for this loop, because e is equals to k. So, and this loop runs from e minus e is equals to n minus k only. So here we are getting the time complexity as k plus n minus k. So finally we are getting the time complexity as order of n, and the space complexity is order of 1. So we have reduced the space complexity, we have optimized for it, and also in this the time complexity is optimized. So initially in the brute force you can see that it was order of n square, but now with the sliding window protocol we are getting the time complexity as order of n, and space complexity as order of 1 only. So you have seen the work of the sliding window protocol with an example. So this is it for this video. I hope you have understood the concept of sliding window protocol with a coding example. And if there is a problem, just comment out in the comment box. And also, if you have to give some suggestions, please comment out there. And sorry for being late for coming out with a new video. We'll try to come regularly with some new videos with some new interesting concepts in data structure. and and if you like this video, please hit the like button and do subscribe to our channel. Thank you.